Today we will continue solving single variable inequalities in one step, using addition, subtraction, multiplication, or division. But our examples today will have fractions or decimals. So let's get started. The great thing about math is it doesn't really change much. Those same skills and concepts we use to solve inequalities when we add integers will be used to solve inequalities with fractions and decimals. Here we have x plus 2/3 less than or equal to -2. So 2/3 is added to our variable. So to undo that addition, we will use subtraction. And we will subtract 2/3 from both sides. X is by itself. And then we have less than or equal to. Here we have -2 minus 2/3. So we'll need a common denominator. 3 will be that common denominator. So we need to rewrite -2 with a denominator of 3. That's -6/3 minus 2/3. And we get x less than or equal to -8/3. Now rewriting this as a mixed number, we have -2 and 2/3. So -8/3 is going to fall between -2 and -3. And we'll put a closed circle there, indicating that -2 and 2/3 or -8/3 is a solution, and x is less than -8/3. So we'll shade everything to the left or smaller than -8/3. All numbers less than or equal to -8/3 are a solution to this inequality. Again, we will check a few points. Let's check at -8/3 first. So at x equal to -8/3, we have -8/3 plus 2/3 less than or equal to -2. This is -6/3 less than or equal to -2, and then -2 less than or equal to -2. Let's check one more within this solution. So we have -6 right here. Again, you can pick any point smaller than -8/3. We've already checked -8/3. So now we're going to check anything smaller than that. And -6 is smaller than -8/3. So at x equal to -6, we have -6 plus 2/3 less than or equal to -2. We need a common denominator. This is -18/3 plus 2/3 less than or equal to -2. Now we have -16/3 less than or equal to -2. So -16/3, 3 goes into 16 5 times, so that's -5 and 1/3. And that's less than or equal to -2. So that's a true statement. And our solution are all numbers less than or equal to -8/3. Looking at a decimal, we have 3.2 greater than -8y. So in this case, our variable is multiplied to -8. So to undo multiplication, we're going to divide by -8. And what we do to one side, we have to do to the other. So we'll divide the left side by -8. This gives us y by itself on the right side. And on the left side, we get -0.4. We divided by a negative, so we will switch the direction of the inequality symbol. We'll rewrite this inequality with the variable on the left, so we get y greater than -0.4. We can define the length of these ticks to anything we want. So we have -0.4, that's between 0 and -1. So I'll put 0 here, and we'll make each tick 2/10. So here we have -0.2. This is -0.4, -0.6, -0.8, and then this is -1. We have an open circle at -0.4. And then we'll shade everything greater than negative 0.4. All the numbers greater than negative 0.4 are solutions to this inequality. Checking a few points. Again, I will check where the two sides are equal. That is where our circle is, our point. So at y equal to negative 0.4, we have 3.2 greater than negative 8 times negative 0.4. This is 3.2 greater than 3.2. And this is not a true statement because negative 0.4 is not a solution to this inequality, but it is the boundary of the inequality. And if 0 is available, I highly recommend testing that point because the math usually is pretty simple. So at y equal to 0, we have 3.2 greater than negative 8 times 0. 3.2 is greater than 0, and that's a true statement. Our solution is y greater than negative 0.4. With the third problem, we have negative 5/6 x less than negative 3/4. X is multiplied by negative 5/6, so we're going to multiply by that reciprocal. So we have negative 6/5 is the reciprocal of negative 5/6. And then we'll multiply the other side by negative 6/5 as well. Now on the left, everything cancels out. These two multiplied together are 1. So we have x on the left, and then negative 3/4 times negative 6/5. Well, we cancel these out. That's a 2 and a 3. We're multiplying a negative times a negative, so this will be a positive number. 3 times 3 is 9. 2 times 5 is 10. And then we multiplied by a negative, so we'll switch the direction of the inequality symbol. Now 9/10, we could also write that as a decimal. This is 0.9. Let's again use tick marks. They're 2/10. So we'll have 0 here, and that'll place 1 right here. Now this is 0.8, so 0.9 is going to be right between these two, and it's an open circle. 0.9, or 9/10, is not in the solution, but everything greater than 9/10 is a solution. Let's check a few points. Again, we will check where they are equal first. So at 9/10, at x equal to 9/10, we have negative 5/6 times 9/10 less than negative 3/4. So we can cancel a few things out. This 5 becomes a 1, the 10 becomes a 2. And then with the 6 and the 9, we have a 3 and then a 2. So that's going to leave us negative 3/4 on the left, less than negative 3/4 on the right. Again, this is not a true statement, but it is where the two sides are equal to each other in the boundary of that inequality. Let's check another point. In this case, let's check 2. So at x equal to 2, we have negative 5/6 times 2 less than negative 3/4. This is going to give us negative 10 all over 6 less than or equal to negative 3/4. And we can rewrite negative 10/6 as negative 1 2/3 less than negative 3/4. And this is a true statement. The left side is smaller than negative 1, whereas the right side is greater than negative 1. The solutions are all numbers greater than 9/10. For this last problem, we can simplify down the right side of this inequality first. So we have 7.5 less than or equal to 9/10 plus 6/10 is 1.5 or 1.5 y. Our variable is multiplied by 1.5, so we'll divide it by 1.5. We'll do that to the other side as well. And so 7.5 divided by 1.5 is going to give you the same value as 75 divided by 15. Either way, you get 5, less than or equal to y. And then we will rewrite this with our variable on the left-hand side, y greater than or equal to 5. We will place 5 on our number line with a closed circle because 5 is a solution to this inequality. And the solution contains all numbers greater than or equal to 5. Let's verify 5 first. So we have y equal to 5. 7.5 less than or equal to 0.9 times 5 plus 0.6 times 5. So now we have 7.5 less than or equal to. So this is like 9 times 5, which is 45, but then it has the 1 decimal place. So that's 4.5. 6 times 5 is 30, so this becomes plus 3. So we have 7.5 less than or equal to 7.5. That's a true statement, and it's where the two sides of the inequality are equal. Next, let's try 10. So we have y equal to 10. So 7.5 less than or equal to 0.9 times 10 plus 0.6 times 10. Now we have 7.5 less than or equal. Well, this is 9 plus 6. So we have 7.5 less than or equal to 15. And that's a true statement. The solution is y greater than or equal to 5. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these 4 problems. For the first problem, 1/2 is subtracted from our variable, so we'll add 1/2 to both sides. No change in the direction of the inequality when we add or subtract across that inequality symbol. We end up with a less than or equal to 7/4. The second problem, we have negative 18b less than negative 28.8. So we're going to divide both sides by negative 18. We divided by a negative, so we switch the direction of the inequality symbol. We end up with b greater than 1.6. In this third problem, we have mixed numbers on both sides of that inequality. So the first step I did was convert these to improper fractions. From there, we have 21/10 times our variable. So we multiply by its reciprocal. We end up with c greater than or equal to 5/9. And then finally, the decimal 3.9 is added to our unknown. So we'll subtract 3.9 from both sides, ending up with d less than negative 3.2. Continue practicing solving inequalities, and I'll see you in the next video.